Hello students, welcome to Physics online class. In this video, we'll cover acceleration, uniform and non-uniform acceleration and positive, negative and zero acceleration. So starting with our first topic, which is acceleration. Acceleration meaning increase in velocity. When the velocity of a body is increasing, the body is said to be accelerating. To understand it, let's take an example. Suppose a car starts from rest. Rest meaning its initial velocity, which is represented by u, is equal to 0. And its velocity increases at a steady rate so that after 5 seconds, its velocity is 10 meter per second. Now in 5 seconds, the velocity has increased by 10 meter per second from 0 to 10 meter per second. So here 10 meter per second is the final velocity, which is represented by v. Initial velocity represented by u and final velocity represented by v. In 5 seconds, the velocity increases by 10 meter per second. So in 1 second, the velocity will increase by 10 upon 5, which is 2 meter per second. In other words, the rate at which the velocity increases is 2 meter per second every second. So the car has started from 0, initial velocity 0, and in every second its velocity increased by 2 meter per second, and at the end of 5 seconds its velocity is 10 meter per second. So the car is said to have an acceleration of 2 meter per second square. Car is said to have an acceleration of 2 meter per second square. Acceleration is represented by letter A. So with this example, acceleration of a body can be defined as the rate of change of its velocity with the time. That is, acceleration is equal to change in velocity per unit time. Change in velocity is final velocity minus initial velocity. Acceleration represented by A, final velocity represented by V, initial velocity represented by u, and time taken for the change in velocity is represented by t. So the formula for acceleration is A is equal to v minus u upon t, where A is acceleration of the body, v is final velocity of the body, u is initial velocity of the body, and t is time taken for the change in velocity. The SI unit of acceleration is meter per second square, which is written as meter per second square or meter second minus 2. It is a vector quantity. Now let's understand how the unit of acceleration is meter per second square. We know that the formula for acceleration is A is equal to v minus u upon t, and we also know the SI unit of velocity is meter per second. So in place of change in velocity, we'll write meter per second, and the SI unit of time we know that it is second. So this will be meter per second square. That can be written as meter second minus 2 also. Now let's talk about uniform acceleration. An object is said to have a uniform acceleration if its velocity changes, that is increases or decreases by equal amounts in equal intervals of time. For example, suppose the velocity of an object changes by 2 meter per second every second, then it is said to have uniform acceleration. The example of uniform acceleration is motion of a freely falling body. Freely falling body is the body that falls under the influence of gravity. So such a body that falls under the influence of gravity possesses uniform acceleration. Now talking about the graph, the velocity time graph for a body moving with uniform acceleration. Velocity time meaning we represent a graph between velocity and time. Time is represented in the x-axis while velocity is represented in the y-axis. And the graph for uniform acceleration will be a straight line, like we have read in uniform and non-uniform motion and also in uniform and non-uniform speed. Just like uniform speed and uniform motion, the graphical representation of uniform acceleration will be a straight line. Now talking about non-uniform acceleration. An object is said to have a non-uniform acceleration if its velocity changes, that is increases or decreases by unequal amounts in equal intervals of time. For example, motion of a car on a crowded road. The speed or velocity of a car running on a crowded city road changes continuously. At one moment, the velocity of car increases, whereas at another moment it decreases. So, the movement of a car on a crowded city road is an example of non-uniform acceleration. Now, talking about the velocity time graph for a body having non-uniform acceleration, it is a curved line, just like non-uniform motion and non-uniform speed. When we plot a graph between velocity and time, we get a curved line. So the graph for non-uniform acceleration is a curved line. Now moving towards the last topic, which is types of acceleration, that is positive, negative and zero acceleration. The acceleration is positive when the velocity of a body increases with the time. For example, suppose an object starts from rest, that is initial velocity u is 0 and it attains some velocity, for example 10 meter per second after some time. So here the velocity has increased from 0 to 10. Therefore, the acceleration of the body will be positive. So when v, that is 10, is greater than u, which is 0, the acceleration will be positive. Now talking about negative acceleration. The acceleration is negative when the velocity of a body decreases with the time. Decreases with the time meaning its initial velocity is greater than final velocity. For example, suppose the object is moving with velocity 10 meter per second and the driver suddenly applies brakes. So after some time the car stops. So its final velocity will be 0. Initial velocity, that is 10, is greater than final velocity, which is 0. In this case, the acceleration will be negative. It is also known as retardation or deceleration. Negative acceleration is known by other names, that is retardation or deceleration. Now talking about zero acceleration. The acceleration of a body is 0 when it moves with uniform velocity. Uniform velocity meaning initial velocity is equal to final velocity, that is velocity remains constant throughout the journey. Now let's understand how acceleration is 0 when the body moves with constant velocity. We know the formula of acceleration, which is v minus u upon t. Suppose a body is moving with the velocity 2 meter per second throughout its journey. So in place of v we will write 2, in place of u we will write 2 and time taken is t. So 2 minus 2 will be 0. Therefore the acceleration of the body is 0. So this is all about acceleration and its types. Thank you. See you in the next video.